In this video, we're going to learn how to work with Scapy, which is a highly versatile Python module for all things network traffic analysis, sniffing, packet manipulation, and much more. So to kick things off, if you don't have it installed, open up a command prompt if you're in Windows, or a terminal if you're in Linux, and type pip or pip3 install Scapy. And that's it. Oh, and if I failed to mention in previous videos, I'm using Python 3 in Windows 10. Now, one of the best ways to learn about Scapy is by visiting the official documentation at scapy.net. And of course, there are many entire books written on this module, so you can check that yourself if you're interested. And I need to point out that most of what I'm doing here and in the rest of the videos does not come from my stellar original thinking. I'm also getting inspiration from many books, courses, websites, and over here I'm going to specify the best of them in the resources that may accompany this video or this course. Alright, so Scapy. Now, you can work with Scapy in multiple ways. Once you have it installed and added to your path environment variable, you can use it directly in the command line or in the terminal by typing Scapy. And it's going to pop up a Scapy shell, or you can simply use it in scripts such as importing it in Python and using it accordingly. Now let's start with the first one and look into a few basic commands. So in terminal, I'm simply going to type Scapy, hit enter, and we're going to see a Scapy shell popping up. And like I said, Scapy lets you craft, manipulate, and forge network packets. Not only that, but it also allows us to sniff and dissect packets from all over the network across multiple layers of the OSI model. Therefore, you can use Scapy for both good and malicious purposes, and my intention is to encourage you to find only good uses to it. Now, what are some of the commands that are mostly used in Scapy? So first we have the ls, which gives us a huge amount of the protocols supported by Scapy. There's no reason for me to actually go through all of them. And there's also the lsc, which is a list of commands we can run interactively in this shell. There's also the conf to display and also to modify the current configuration. And if you're ever in trouble, you can type help and give it as parameter whatever you want to find more information about. For example, RDP cap. Okay. Now let's get practical. So let's actually craft a simple packet at the IP layer. We'll say pack underscore IP. We'll give it a destination equals dgtsec.com, which is one of my websites. TTL time to live 10. And that's basically all you need to do to create a packet. Hit enter, and we can look into it with pack underscore .show. We can see the protocol, the IP, the source, destination, checksum, length, and other stuff. And remember, I told you about the configuration over here. Let's make this packet display more nicely by modifying the configuration. So in the conf over here, we can see a variable color theme, black and white. To have a nicer display of the output in Scapy, we can modify this color.theme, color underscore theme. So we'll do conf.color underscore theme. This is going to be color, so color on black theme. Hit enter, no color on black. Color on black theme. So theme, alright, yeah. You can get a sneak preview of it already being modified. Now we can repeat the command with pack underscore .show, and as you can see, this looks much better. I said that the Scapy also lets us deeply analyze and sniff network traffic similar to Wireshark and TCP dump. Let's just do that on my Wi-Fi network. So what we need first is to provide Scapy with the network interface and the number of packets we want to sniff. You could sniff continuously and break the sniffer whenever you want, and then you'd be analyzing the packets you sniffed up until the breakpoint. But we'll just do the first version. So let's actually get to the name of my Wi-Fi with iFaces from interfaces, and my Wi-Fi in this case is Intel Wireless AC this 9562. We'll actually copy this name and then create a sniffer. So let's say sniffer underscore equals sniff on iFace, so interface, and then paste my interface name and the number of packets we want to sniff, let's say 15. Now this might take a little while to collect 15 packets, and it's done. And then we can simply sniffer underscore dot show, and we get a nice summary overview of each packet, such as the type, the layer, the source to destination, port, etc. We can get deeper into each packet using indexes. So we can say sniffer underscore index 5 dot show, and we can see that sixth packet, so 0, 1, 2, 3, 4, 5, this packet from 172. So we have the destination 195, 108, the source, the destination, and all the information with respect to this packet. If we want to access the load of the packet, we could simply say sniffer underscore dot, so without the dot 5 dot load, and this is the raw load of the packet. But we can do a hex dump with a hex dump sniffer underscore 5 of the load, and we get the hex dump of the load, or we can do a hex dump of the entire packet itself, and we can see the hex dump of the entire packet itself. Okay, there are thousands of interesting things you can do with all of these and the rest of the methods. You could, for example, sniff continuously and only filter into the output the packets that contain certain information such as usernames, passwords, hacking attempts, etc. And in this case, the sniffer method has a lot of parameters it can take, including iFace for the interface and count, as we saw, PRN, which allows us to specify a function to run on each packet, timeout to stop the sniffer after a given time, filters, etc. Now let's also take the example of sniffing with filters for a specific host, one of my current websites, dgtsec.com. So we'll say sniffer, sniff, and then we'll specify a filter equals, but first we need to get the IP of dgtsec.com, so we'll do that with a ping. We'll simply ping dgtsec.com and get the IP 162, copy this, and then let's specify a filter for port 443 and host the IP, and then let's sniff for 15 packets and specify a lambda function, so lmbda(x). We're going to look at the summary of each packet. Alright, and now if I do a refresh on dgtsec.com, we can see it populated the sniffer. It actually took the first 15 packets and gathered their summary using the lambda function with define. Now I could write this sniff session to file with wrp cap, so write packet. The file is going to be dgt.cap, and we want to write the sniffer to file. Okay, and then we can read it with rdpcap. We specify the file dgt.cap, and that's it. And it tells us that it has 15 packets if I do rdpcap. I can do the entire thing in a variable, so let's call it read underscore dot cap rdpcap dgt.cap. We have it instantiated in a variable, and then we'll say read cap let's say look at index 5, and once again we have all the information there. Okay, now let's take the example of sending a simple packet and receiving its response. We can send packets at different layers, but let's just create and send one at layer 3. Let's call it packet_t, IP, destination once again dgtsec.com, over ICMP, and then let's say you are not secured, and then we send this packet with the SR method. So we'll say SR packet_.t. This actually sends the packet. We can see the output finished sending one packet. Or we could write a variable, for example, let's say resp from response SR packet, which is basically the same thing. But since this is a variable, we can look into it with resp 0.summary, and we get its details. Now, to give you an idea of what you can further do is that with Scapy you can also do port scans and trace routes using some of the methods I specified here. You could, for example, spoof IP, and you could do SYN flooding, and these two actually often come in a combination. Now, in terms of scripting with Scapy and Python, let's actually take an example of a script for SYN flooding. And this is an example inspired by T.J. O'Connor's book Violent Python. So for that, let's actually go into the code editor here, Visual Basic, and type from Scapy.all import everything. This is how it's usually done. Instead of just importing Scapy, we just from Scapy.all import everything. Now let's define a function called floods. So floods, which is going to take two parameters, a source and a target, and then for, let's say, source underscore p in range 100, 150, or I could say 0 to 50, what we want to do is to have an IP layer, IP, so we define a packet here with the source being the source, the destination being the target, and then we also need to specify a TCP layer, which is going to be TCP source port, so S port, which is source port, it's going to be source P, which we've defined over here, and then D port, which is the destination port. Let's say we want to send this chain of packets to port 600. And then we create the packet using IP layer over TCP, not connecting, but layer. And ultimately we'll say send PKT. Alright, now exiting the loop, we define a source, which is localhost, so I'm going to flood myself, 001, and then target is going to be, it's not actually that I'm going to flood myself, because this is the source is myself, and I'm going to send the target to, let's say, what was the IP of dgtsec.com? One more time. I think it's this one. Let's see. So again, we take the IP of dgtsec.com and send like 50 inoffensive packets, which is low. We cannot consider that a flood. And finally, what we want to do is to run the floods from source to the target, and that's it. Control S to save this. And then in a command prompt over here, we navigate to the desktop where we have the script, the floods.py, and we can simply Python floods.py, and we can see it sent actually it sent 50 packets. However, as you can imagine, if I modify the range, instead of 50 packets, I would be sending a couple of thousands. That means that I would be sending TCP SYN to the target and fill up their connection queue, meaning that I would be actually flooding and impairing them in sending reset packets. And this is just a sneak preview of what the Scapy is actually capable of. I've only shown you here a very small part of its capacity, and there's more to that, such as packet injection and deep packet analysis, for example, and network scanning, network filtering, advanced packet crafting, and much more. Again, I highly encourage you to look into the official documentation and into the books written on Scapy for a more in-depth understanding of this amazing Python tool. It's like I always say, the only limit is your imagination.